Hello everyone. My name is Supriya Bhosle, Assistant Professor, Computer Engineering Department from AISSMS Institute of Information Technology. Today we learn about the concept related to data structure and algorithm. Topic name is types of linked list. So this is about the type of linked list. There are the three types of linked list. The first one is a singly linked list, second one doubly linked list, and the third one is circular linked list. So in singly linked list, the atom navigate is forward only. So singly linked list is basically unidirectional linked list. So you can only traverse it in one direction, that is from head node to tail node. Suppose consider in this example, the head node is actually store the address of first node. So the first node is nothing but you can denote it as a head node, and the last node in the list is denoted with the tail node. In singly linked list, when we have to searching the data in a sequential format, first is visit the head, then the next node in the list. So it visit first 10, then 20. After this, the node structure is not connected further. So the tail node next pointer is always denoted with a null that indicate that this is the end of that linked list. The next one is doubly linked list. In doubly linked list, atom can be navigate forward and backward direction. So it is called as a bidirectional linked list. You can traverse it in a both direction, unlike in singly linked list. Singly linked list does not allow you to traverse in a both direction. We can travel only in a forward direction only. But in doubly linked list, we can traverse in a forward direction and you can traverse in a backward direction also. So here it requires two pointers. One pointer for forward direction and the second pointer is for backward direction traverse. So here you can traverse in both direction unlike singly linked list. This pointer pointing to the previous node to traverse in a reverse direction. So in this diagram, this is a head. Head is toward the address of first node, right? First node is connected to the second node. Second node is connected to the third node. Same like by using a previous pointer, the third node is connected to the second node and the second node is connected to the first node. Likewise, you can traverse in a forward as well as a backward direction. The next one is a circular linked list. In circular linked list is a unidirectional linked list. So you can traverse it in a only direction. But this type of linked list has its last node pointing to the head node. Means suppose you are considering in this example there are the three node. The head node store the address of first node, that is nothing but this node. Then the second node store the address of this node, last node, third node, and the third node next is not connected to the null. This next is connected to again a first node in the list. So it automatically become a circle. This type of linked list has last node pointing to the head node. So traversing, you need to careful and stop the traversing when you revisit the head node. So this is about the circular linked list. These are the basic operation you can perform on a linked list, any type of linked list. The first one is a creation. Create a new linked list. Suppose you want to create a new linked list and store the data. So we are going to use here a creation operation. The next one is the insertion operation. The linked list allows you to add an atom into the linked list by using an insertion operation. Suppose already you have a linked list and you want to insert a new atom inside the linked list. So we are using the insertion operation here to insert the new node in a link structure. Deletion. Suppose you want to delete some specific element from an linked list. So we are going to use a delete operation. Next one is a display operation. Suppose you want to display just complete list. So we are going to use a display operation. Search. Suppose you want to search an element from a given key. So you can search it by using a search function in a linked list. Sorting. Suppose you want to sort an list and the atoms are stored in a form of linked list. So we can use a sorting operation here to sort an element in the list. Reverse. The list will get a reverse by using a reverse operation. The last one is a merging of sorted and unsorted list by using a merging operation. So these are the basic operations performed on a linked list. This is about the singly linked list. So when we are to consider the node structure, every node is having a two field, the data field and the next field. Next field is nothing but the address. It stores the address of the next node for the connection. Each node has only one next part, and each next part contains the address of next node in the list. So the next part of the last node contains the null, which indicate that this is the end of your linked list. Suppose consider in this example, the head node store the address of this first node. This first node store the address of this node, second node, and the second node next field will be null because it is not further connected anywhere. So it will be considered as this is the end of your linked list, and your next pointer address we are set to the null. So it indicates or signifies the end of the node. This is a schematic representation of singly linked list, same like the previous. The head is always store the address of first node, and in node structure there are the two nodes with the data 10 and 20. They are connected with each other. The last node next field will be null. This indicates or signifies the end of the node structure. Each node contains a value and the pointer to the next node in the list. Head is a header pointer which point out into the first node in the list. So when we are going to create a new node here, so it create a node structure. How to define a structure? By using the keyword struct node. Inside that we have to define the data. Suppose you want to store the data which is represented in a form of integer. So we are going to use here a data type integer and data. So data stored in the node which is in a form of integer. The second field or the variable we are declared, that is a type of node. So node star is nothing but the pointer, because in a next field you want to store the address. So the node star next is nothing but the pointer to the next node in the list. So this is about the example of creation of node structure with the data value 10 and the next field is null. Means the uh, linked list is having only one node which is having a data 10, and this is an end node. That's why the next pointer will be set null. So here, while creating a class for the linked list, we have to follow some steps of programming. Suppose creating a class for singly linked list. First, we have to declare a class. Class singly linked list is the name of class. In private section, we have to denote a head pointer because head is required. It stores the address of first node in a linked list. So we are creating the pointer head which store the address of first node. In public, we are defining here the constructor to initialize the list. So here we are going to use the constructor which is similar the name of your class. So singly linked list is a default constructor we are using here, and the null pointer is assigned to the head. Means suppose we are creating a new linked list. At that time your head is become a null because there is no node present in a linked list. So by default initially we are initialize the head pointer with a null. So initially the list is empty. This is indication of list is empty. So thank you.